Hey, hello everyone, friends, and sorry for joining in late. There was some glitch in the Zoom account, so I had to join in a little, a little late. So today we are going to talk about a specific project, which is called as Appointment Scheduler for Sample Collection. And sample collection, a lot of you all must be already aware. And thanks to COVID, the awareness of sample collection has increased even further. Friends, whenever you're sick or when you want to get your complete body check done, or for whatever reasons, additional tests might be needed. And for those additional tests, samples from your body should be collected, ranging from blood sample to urine sample, right? And if doctor says that I sense there could be some tumor which could be cancerous, malignant, cancerous, then for biopsy, they're going to take one sample. Usually in hospitals also, the place where they collect the samples, usually they do not perform the tests over there. Or maybe a few tests are performed in the hospital where you give your sample, and a few other tests might be performed at a lab, okay, such as pathcare labs, etc. There are a lot of labs which exist who are specialized in collecting the samples of blood or tumor for biopsy or urine or whatever samples. And these samples are tested for various conditions in lab. A few of these samples should reach the testing center within some defined time. For example, maybe if some tumor is taken out and if it has to be sent for biopsy to a lab for testing purpose, maybe it has to be sent within 1 hour. Otherwise, it becomes useless. And again, you need to call that particular patient to the hospital. And again, you need to take a slight portion of the tumor. They usually prick a needle, and that needle portion of tumor is taken for biopsy. Usually it is done when they sense that your tumor could be cancerous. Cancerous means it will spread to the other organs and it will not allow your other organs to function properly. Okay, so now, since certain samples should reach the destination before it expires, otherwise, even if you do tests, it doesn't give you any result. And calling a patient again for taking some tumor or some blood for testing purpose doesn't make sense. Patient will not be happy. In order to counter all that, and sometimes what happens is substandard hospitals or substandard labs, testing labs, they will generate some report and then share it with the patient. Hence they keep saying, right, please take a second opinion or a third opinion. If there is any difference in these reports, then you can sue them, saying that, boss, you are saying I do not have cancer, but the other two labs are saying I have cancer. Where is the mistake? And then you can sue them. So the labs are very, very particular to provide the correct data. And the hospitals are also very particular in ensuring that the samples that they take from the patients are tested on time before that gets expired. And those are the kind of business problems that this particular project aims to handle. And this is the content. We will talk about the project overview. We'll talk about CRISP MLQ methodology, objectives, constraints, the technical stack, project architecture, how the data collection happened, description of the data, and data understanding. Model selection and model building and deployment would be explained to you all next week. Okay, so we split each and every project presentation into two parts. One is the theory, where you understand the business problem, and another is the practical aspect of it. So let's proceed further. This particular project aims to streamline and give an appropriate schedule for sample collection. If you are going to go and collect a sample, to ensure that that sample reaches the testing lab on time or before time, you need to also choose an appropriate time of the day. The reason being, sometimes you'll have heavy traffic, maybe you'll not reach the destination. Sometimes you might have less traffic, you might reach beforehand. If there is going to be less traffic at a specific time, then you can collect 2 or 3 different other samples from other different hospitals or different patients directly, and then get it to your testing lab. So that the headache of, or the rigmarole of you going to each and every customer, each and every patient, each and every hospital separately is reduced. So the project aims to streamline and give an appropriate schedule for sample collection to ensure zero sample loss. We don't want any sample to be lost. Lost in the sense, if you take some blood sample and if it has to be tested within 1 hour, if you reach the lab after 1 hour, then it's considered to be lost sample. Storage of the samples and handling of the samples are extremely necessary to maintain the integrity of time. To ensure that your sample reaches the destination on time, you need to ensure that your storage and the handling of the sample, right, both has to be appropriate. And to avoid delay in sample collection and deliverables to diagnostic centers, collect some samples, deliverables, you need to give it to the diagnostic centers. To avoid any delay in doing that, ML model, machine learning model, can be built, which will help to give appropriate schedule, appropriate date and time on when the sample should be collected, such that sample is going to reach the diagnostic center or the testing lab on time or before time. So the ML model will help in analyzing the factors influencing the sample collection and alter them accordingly to ensure zero sample loss is achieved. So ML model will help in analyzing the various inputs or the factors like traffic, amount of traffic that we will have on a weekend versus a weekday, at 6 a.m. versus 6 p.m. It varies. So you need to understand. And there might be a lot of samples that you might want to collect if there is a new virus, like we had Omicron, different variants of Omicron. Certain Omicron variants are non-dangerous. Certain Omicron variants are spreading fast. But we should be really concerned. Because if there's a new variant, that means more number of people would like to get tested. You need to collect more amount of samples. Would you ensure that all these samples reach the diagnostic center on time or before time? Can you assure that? We really don't know if we do not have a prediction done upfront. If a prediction is done using some machine learning models, then it will be a different ballgame altogether. Next. After analyzing the pattern from the data, the model will help the diagnostic centers to collect the samples on time. So this is about the introduction to this project. And we have CRISP MLQ, which is the most widely used machine learning methodology today. And whenever you handle any data related projects, data mining or data science, etc., applying a structured methodology will ensure that you succeed on the project faster. So we have business and data understanding, which is phase 1. Then we have data preparation or data engineering phase 2. Then we have model building as phase 3, model testing and evaluation as phase 4. You deploy your model and then you monitor and maintain. Based on your monitoring and maintenance, you keep tweaking your model, okay, as needed. Okay. So here are the business objectives. Minimize the sample loss, the samples that you're collecting. Ensure that it reaches the diagnostic centers on time or before time. If it doesn't reach on time, then the sample is called as sample loss. You cannot use it for any tests. You cannot do any, oncology related tests. If it's a tumor, right, then pathology tests, etc., cannot be performed. So you want to minimize that loss. Vis-a-vis, you also want to maximize the productivity of sample collection agents. So in this specific project, we also have looked at what should be the most appropriate route. Okay, network analytics. If a person is here, the sample collection agent, maybe he has to go to this house, okay, to collect the sample, and then he has to go to this house, and then this person has to reach the the diagnostic center, right? Maybe this guy would collect another sample here, and then this person has to see, this person collection agent is here, start point, and then this person has to somewhere go here. So say you have the hospital here or diagnostic centers where the tests are performed. I mean, the samples are tested and then reports are generated. In that case, what you can do is you can say that this particular agent, sample collection agent, will go to this customer A, will go to this other diagnostic center B, and then he'll come to the lab where testing happens rather than going to this route. So this route you'll assign someone else to travel. So this way, if you are going to devise your network properly on from which path to which path should I travel, etc., that is called as network route optimization. Network route optimization. Then we also have constraints. As part of constraints, you know for a fact that model might get impacted by unforeseen conditions such as weather conditions. If it suddenly starts raining heavily, you might not reach your destinations on time. If you have certain traffic conditions, okay, if the traffic conditions are worse, that means if there's huge traffic, etc., then also you might not reach the destination on time. Suddenly there is Prime Minister visit, suppose, to Hyderabad, and you're collecting the sample and it is in the route where Prime Minister would travel, then you'll experience traffic jam. You need to consider all those aspects. Sometimes you want to collect the sample, patient says, please come, and patient is unavailable. Patient might say, you know what, suddenly I had some emergency, I came out. So agents might not be able to collect the sample. Or maybe agent promises that I'll come to your place at 6 p.m., but there was heavy traffic, so he could not reach. And so, hence you left the place. Right? Many constraints would be there. So what we have done is, before we got started on this project, we tried to understand what is the technology stack that we need to use. And then we freezed on a SQL database to capture the data. And we figured on, we zeroed in on PostgreSQL, which is used to import and export data into database. Then for deployment purpose, we used Heroku. CLI means command line interface. Command line interface is like a terminal. Okay, or you can call it as a command prompt on which you're going to issue commands. It is used to deploy the model. And we also have a lot of IDEs, integrated development environments. And these are essential building blocks. Okay. And you can use Spider, you can use Jupyter, etc. Okay, to be able to perform the operations. And then we also have Tableau, which is a business intelligence tool, which is used for data analysis or descriptive analytics. And then for proof of concept, we have used web framework using Flask, HTML, and CSS. Now, we are going to also practically show you on how to implement the project in the next week as part of part 2 of the project. And we are going to explain you on how all these things were integrated so that you understand from data engineering standpoint also, which is becoming very, very important nowadays. Data engineering, people are expecting a lot. So you understand business and data, then you understand the project objectives and constraints, then you collect the data through various forums. You store that in some database. Here we have used PostgreSQL. Then you use one of the interfaces, Spider or Jupyter, etc., and then establish a connection between Postgres and your IDE using some Python connection. Then you are going to perform data pre-processing. Then you perform exploratory data analysis. Then you perform data visualization using Plotly, so on and so forth. And then you build the model. After building the model, you're going to evaluate the model. After evaluating different models, you select the most appropriate model. Okay. And then you're going to deploy a model in using some framework. Here we are using Heroku. And after you deploy the model, you can start using the model for predictions. And once you get the prediction results, you're going to save the prediction results back in database so that you can monitor the changes in the data, changes in the prediction results, etc. And you can upgrade your model as needed. Model upgradation as needed. And here we have data collection and description. Data collection is done using simulation techniques. We simulated a lot of data. Okay. We had some data. Using that, we simulated to generate more data. Okay. And we also reached out to various diagnostic centers to collect the inputs. And data is imported into Python from our DBMS source, Relational Database Management System. From that, data was imported into Python for further analysis. And here is a brief understanding on the data. We had various variables such as patient ID, which is the ID number given to the patient upon booking for the test. What was the age of the patient, gender of the patient, what was the test which was performed, right? And what kind of urine was collected? Was it a swab test or blood test or urine test, etc.? And how was it stored? We have storage of sample. Okay. Do you have some advanced storage system or a normal storage system? Advanced storage system means if probably your blood is taken, maybe that blood sample should be maintained at a specific temperature. Okay, maybe it has to be maintained at a specific temperature to ensure that when you do the test, you get the appropriate results. And then when was the test booked? What was the time? These two are very important because is it a weekday or a weekend? Is it morning or afternoon or evening? Is it non-peak hours or peak hours for traffic to be analyzed? Then you also have sample collection date. When was the sample collected? Right? And then you have scheduled sample collection. The time of the day at which the sample must be collected from the patient. This is your output variable. This is what you want to predict. Cutoff schedule, the time of the day when the test is performed on samples. You collect the sample, take it to the lab, and then they will do tests. Within what time should you reach? Given the date and time when you're going to collect the sample, within what time should you reach for the test to be completed? This also is important. And remaining are called as inputs, friends. I'm sure you all are aware of that. Right? So you have all these features or inputs or variables or columns which you'll have in the data. And you also have Y. Usually this Y, which is your output variable, is called as dependent variable. Okay, or your target variable. Because this is what you need to predict. Oops. And there were other inputs also which were considered. What is the cutoff time? Not just date, but what is the cutoff time as well? Who is the agent? Because historically, maybe a few agents are very disciplined. So they take the sample and reach the destination for testing on time. Or maybe they are rash drivers, who knows? So you need to understand all those aspects. You cannot afford to have a rash agent just because he's able to deliver the samples, faster to your labs, right? So all those aspects have to be considered. Some agent is helping you ensure that all these samples are reaching you faster. Does not mean he's a good agent. Could be their rash drivers. You need to look into good and bad aspects. Traffic conditions, we have low traffic or medium traffic or high traffic. Usually you can get the traffic data real time by making use of Google Maps APIs or some maps, whatever maps you use. There'll be application programming interface, API. You connect that API and you keep fetching real-time data. But the moment you establish an API, for every request you ask for the real-time traffic data, you'll be charged by Google, or there's something called as Waze, etc. They charge for you. So you have to also bear in mind the cost associated. And always when you're working on projects, you might feel that there are far too many variables that you can think about, which would help you predict your output. At the same time, you need to also ask yourself on, is that data already available with us? If that data is not available with us, and if you want to go now and collect the data, that would be a very costly affair. Okay, and you also have agent location. What is the distance of the agent from patient's location in kilometers? That also a data message. Time taken to reach the patient, time taken for sample collection. All these are important. How much time are you taking to reach the patient? How much time are you actually taking to just get the sample out? And these two were given in minutes. Lab location, time taken to reach the patient. Of course, you need to look at traffic conditions, but here what we have done is we have not used Google Maps to get the real-time traffic data. We just assume some ideal traffic conditions that, uh, you know, if you are traveling in afternoon, right, or after 11 a.m. until maybe 12:30 p.m., traffic would be least. That's the ideal thing that you're thinking about. But maybe some construction is going on there. Someone met with an accident, or some celebrities inaugurating a store in that location, or some politician is coming. So all these things would mean you need access to Google API. Then you have time taken to reach the lab. Okay, how much time would you take? Again, the ideal traffic conditions were assumed as opposed to taking the Google API limits and all, right, because it's cost. What is the mode of transportation? Is it based on bike or car? How? And whether the sample has reached on time or not for the test to happen. So in this way, we had bunch of inputs that we have considered for completing this project on time. And then we performed exploratory data analysis. Exploratory data analysis, which is also called as descriptive statistics, has certain stages which have to be performed correctly, like first moment business decision, second moment business decision, third moment business decision, fourth moment, and also we have graphical representation. Then, as part of as part of exploratory data analysis, you also need to look at how many variables you had, how many columns or features or variables you have, how many rows or observations did you have? Do you have any missing values? Do you have any duplicate rows? What is the total size of the data set? So what happens is when you have your data set in your database, say SQL, some SQL database, and if you're going to load in Python, Python stores the data in memory so that it can process the data faster. And if you have, say, 8 GB RAM, then out of 8 GB, how much memory is consumed? 115 KB. Then you have categorical data. How many numerical variables were there? How many date related variables were there? All this is given. Then as part of exploratory data analysis, you also perform certain interesting visualizations. Here, there was a probability distribution done on patient age, and you understand that maximum number of patients who are getting the tests done are in the age group of 30 to 50. Because if you see here, approximately 30, if you see here approximately 15, that way you have many people. Then you also have sample. What kind of sample are you collecting? Is it more of swab, or is it more of urine, or is it more of blood? It's a blood which is getting collected maximum number of times. And we have normal temperature versus advanced, right? So normal storage, they just take it in the regular bag and move, right? So those are more here. Whether they have reached on time, yes or no, is also given. Then here you have 90% samples are delivered on time, right, in low traffic conditions. When the traffic is very low, a lot of samples reach the diagnostic centers or labs, test labs on time. If you have high traffic, it's yes, you are also trying to ensure that samples reach on time, but in comparison to low traffic, high traffic, you're losing out a lot of samples. Then we have also performed correlation coefficient analysis. This is correlation coefficient matrix or a table. which explains the correlation between all the possible variables that you have. And then from this, all those which are unimportant are removed. Like scheduled sample collection time is your output variable. What is the correlation of all the other variables with this? If there is very less correlation between the output variable this and the other input variables, then you can ignore those. They will not add any value to your model that you're building. Okay. Then we had tried to look at whether we have any missing values, duplicate data, do you have any irrelevant data. So ensuring that you capture only relevant data, can be performed using your common sense. I usually call this domain knowledge as common sense. So that is very important, right? And then you have some statistical tests like hypothesis testing and various other techniques such as variable information plot, information gain, lasso regression, bunch of other techniques exist, which will help you figure out what are the most important features. Now we have SHAP values, line values. All these are the different values which help you figure out what variables really make sense. Then we also perform one-hot encoding to ensure that nominal data or ordinal data, or for that case, categorical data, is converted into numeric data. In this particular data set, there were no outliers, so we just ignored that part. So the same data was returned. Then data visualization. The data was imbalanced data set. So we converted that imbalanced data set into balanced. How did we do that? The number of yes cases were more, meaning did the specific variable, so did the specific sample reach on time or not? But then we are trying to predict the time, whether it is going to reach on time or not, or you want to predict the exact time, date and time when you need to go and collect the sample so that it reaches on time. That is one side of the story. That is our end objective. That is our end objective. But are you going to reach on time or not? If some predictions happen, and if you come to know that you're going to reach on time, right, then you can be rest assured, you can be happy. But if you know that you're not going to reach on time, then you can you can take corrective actions. These are all predictions. What will predictions help you do? Take proactive decisions. If one of the sample cannot reach the diagnostic centers on time, if you know that, if you predicted that, then do something else. Change the scheduled sample collection time during business hours. Sorry, not during non-peak hours of traffic, so that you reach that sample on time. So if you have imbalanced data sets, you can make it balanced through various techniques. Here, the technique which was employed was undersampling. Undersampling was a technique which was employed. That means if you have only 200, say, no cases, you'll also ensure that yes cases are also 200. Then we performed complete urine analysis. So urine analysis is what they call it. Those tests has the highest rank in all tests performed. If you look at acute kidney profile or CBC or complete urine analysis, fasting blood sugar, all these tests, you see that this has highest. And 90% of the people who are getting your test done stay within 300 kilometers radius from your diagnostic centers. This is another interesting insight. So maybe for a company which wants to grow and want to go beyond a specific point, maybe you might want to think beyond this. You might say that I'll open new centers, new diagnostic centers, new testing labs, so that I increase the number of kilometers that I cover. Okay, radius of kilometers. Then we have average time required for sample collection, that was 10 minutes. To just inject a syringe and then extract blood, etc., put it in a preform or tube. All these should take or is on an average taking 10 minutes. Average time taken for the sample to reach the lab is 40 minutes. But there are a few samples which are taking 200 minutes, 300 minutes, etc., even 400 minutes. You need to figure out what kind of samples are there. Are these samples which are getting, which are taking more time to reach the lab? How can you reduce it? You can do all that analysis. And then there was also something called as pay plot, which was performed. When it comes to pay plot, you once again can look at the correlation between all the possible variables. You can look at the data distribution of all the variables and various things. But if you have far too many variables, it really doesn't make sense to have this kind of a plot. But nevertheless, certain variables are very strongly correlated. What are those variables, etc.? You can zoom it and then do a thorough analysis. So this is what we wanted to show you as part of part 1. As part of part 2, we want to show you a few other things, and we are going to talk about what were the different models built, how were these models evaluated, and which model was selected finally. Model selection, which model was selected. And then we are going to show you how the model was deployed and what is our model monitoring and maintenance strategy. Model monitoring and maintenance strategy. And finally, after this is done, we are going to show you hands-on. Practically, how did we do that? We are going to open the softwares and then we are going to demonstrate. All right. All this is going to give you immense knowledge to prepare very well to become a successful data scientist. It's not just about theory. It is not about only machine learning algorithms in silos, but it is about all these various phases of crisp MLQ, which will help you ignite your thought process and do a great job as a data scientist, right? And it will also help you explain the projects to the interviewers in a much better manner. So take motivation on these aspects and become successful, friends. Thank you all so much. Do subscribe to our channel so that you get to know about a lot of these amazing sessions which happen almost every week. And do tell to your friends, your colleagues who might get benefited from this. Thank you all once again, and yep, have a good evening. Thank you.